All right, due to technical difficulties, this is my third time doing this, so hopefully it comes through okay. All right, so we're looking at graphing linear inequalities when you have x and y on the same side. And we don't want that, so we're going to walk through how you can solve one of these. So we're looking at number 4 in the worksheet I gave you. You notice that we have x and y on the same side here, they're both on the left. I even give you a hint. Y has to be alone for you to graph the line. So if you try to graph the line as it is without doing anything to your inequality here, you're already off on the wrong foot. Let's start here. So we got 5x plus 2y is less than 1. And our goal here is we want to get y all alone. First thing I'm going to get rid of, I want to get rid of that 5x. There's no need to have 5x over here. I want to get rid of it. So what am I going to do? I'm going to subtract 5x on this side. I'm also going to do it on the other side. Always make sure you're doing it to both sides. So then I get 2y is less than negative 5x plus 1. All right, now my next step here, I want to get that y alone. What's happening to y? If there's a 2 next to it, that means 2 is your coefficient. It's being multiplied. Let's undo that multiplication using some division. Divide by 2. Now notice on the other side, I'm dividing everything by 2. Not just the negative 5x, but also the 1. What happens then? I get y is less than negative 5 over 2x plus 1 half. We don't have whole numbers here for our y-intercept, but that's okay. We can still work with that. That happens sometimes. All right, so what am I going to do? First, now they have my y all alone. I want to graph my y-intercept. So I'm going to graph 1 half. I'm going to go to my graph here. I'm going to approximate about where 1 half should be. Get rid of that. Should be about right here. That's a good approximation. So I've graphed my y-intercept. My next step, I am going to graph my slope. I got negative 5 over 2 for my slope. Remember, slope is change in y over change in x. So I'm going to be going down 5, right 2. So I'm going to go here. I'll use a light marker here, okay. I'm going to go down 1, 2, 3, 4, 5. And then I'm going to go right 2. 1, 2. Awesome. I'm going to do that again. Go down 1, 2, 3, 4, 5 over 1, 2. I've got 3 points here. Ideally, let's get as many as we can in here. So I'm going to go right down here. I went down 5 over 2. Now, over here, I can't exactly go down 5, but what I'm going to do is I'm going to work backwards, and watch what I mean. I'm going to go up 5. 1, 2, 3, 4, 5. And then instead of going to the right this time, I'm going to go left. I'm going to go 1, 2 over. And there we go. And then I'm going to do the same thing up here. 1, 2, 3, 4, 5. Say 1, 2, 3, 4, 5. Good. And then over 1, 2. All right. Let's double check everything came out okay. 1, 2, 3, 4, 5 over 2. 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 Good. And here's always a good check as well. I'm going to draw the line. Now let's check our line. Our inequality is not underlined. So that means we're going to be using dashed lines. We're not going to be using a solid line. So I'm going to connect my dots. Just like so. I've got my dashed line. Here's one thing I like about this line. It's going downwards. I have a negative slope. That's what it should look like. If you have a negative slope, that's what you want it to look like. You want it to be going down. If you're not getting something going down like that, chances are you did something wrong. So always be mindful of that. That can be a bit tricky when it comes to negative slopes. Some people still graph it going upwards, so just be mindful. All right, so now it's telling me y is less. You have a couple of ways you can approach this. I'll show you the way I use, and I'll show you a way that I've seen other people use. So it's telling me y is less. I'm going to look to my line here that I drew. I'm going to look for all those y values that are less. You can find that they're down here in that ballpark. So what am I going to do? I'm going to color everything on this side of the line here. It's like being back in kindergarten where you get to color stuff. It's a lot of fun. All right. And fill in that space. That wasn't good. Looks like I need some practice with my coloring skills. All right. It's still going over the line. You don't want it to go over the line. That's not good. So, and I didn't want to do that either. What happens when you get sloppy, guys? Be careful. All right. So this would be my solution. The other way you could try this. Some people really like this method, and I'll show you how you can use this method. This one's called using a test point. What you do is you have your line here, and you pick a point anywhere on this coordinate grid. 0, 0 is always a good one. Using that origin, why? 0, 0 are always easy numbers to use. So what you would do is you would take that test point and you would plug it into your inequality here. So I'm using the test point 0, 0, which means x is 0, y is 0. Plugging them in. Solve it out. Negative 5 halves times 0 gives me 0. Plus 1 half gives me 1 half. Is 1 half greater than 0? Yes. That's good. That means that 0, 0 would be a solution to this. So that means wherever 0, 0 is, whatever side that is on this line, I shade everything over there in. So there you go. I just walked you through when you have x and y on the same side of a linear inequality. Remember, you want to get y alone, and then you would just solve it like you have been with linear inequalities. Hopefully this helps you.